Salvation International Preparatory School. Salvation International Preparatory School. A place to be, a school to go. We'll build you up from the cradle to university. Salvation International Preparatory School. Salvation International Preparatory School. A place to be, a school to go. We'll build you up from the cradle to university.
Good day, classmates.
Good day, Lydia.
My name is Lydia and I'm We are here to perform our chemistry practical on titration. Firstly, what's titration? Titration is a technique whereby we use the concentration of a known solution to find the concentration of an unknown solution. We have practical questions here which we are going to use the experiments to practice. Firstly, put A into the burette and titrate it against 20 centimeter cube or 25 centimeter cube portion of B. Now he has put in A, which is the acid we are going to use today, is hydrochloric acid, HCl. So next we pipette our base. Then we add 2 to 3 drops of the methyl orange, which is our indicator. Now we proceed by adding our acid into the solution while shaking vigorously. Now the color change has been observed at the reading at 17.2 centimeters. Now we'll proceed with this next experiment. Now we prepare the base. Now we add our indicator, methyl orange, 2 to 3 drops. ended at the value of 23.4. The initial burette reading was at 0.0 and second at 0.00. Now we proceed by filling up the burette to find our second reading. When filling it up, the value must end at 0 to get an accurate reading. Then we proceed again by repeating the base. Then we add our indicator again 2 to 3 drops. Now the color change has been observed and we attained a value of 23. Now to get our titration value, we add the two readings and divide by 2. So therefore, our titration is equals to 23.7 centimeters. So for our questions here, we have A is a solution consisting of 1.83 gram of HCl per 500 centimeter cube of the solution of impure NaHCO3, which is sodium hydrate trioxocarbonate 5, consisting of 9.60 gram per dm. First, put A into the burette and titrate it against 20 centimeter cube or 25 centimeter cube portion of B, which has been done. Using methyl orange as the indicator, tabulate your readings and calculate the average volume of the acid use, which has been done here. From your result information provide the above. Determine the concentration of A in mole per dm cube, B the concentration of B in mole per dm cube, and percentage of purity in sodium hydrate trioxocarbonate 5.
As a parent, I have always asked, how can I prepare my children for the infrastructural development and socio-economic evolution of the next decade? With the ongoing speed of globalization, how can I position my children to perform excellently in a rapidly changing society? The answer is and has always been to give them a solid foundation, academically, spiritually, and morally. Salvation International Preparatory Schools, with her team of highly qualified tutors, conducive environment for learning, state-of-the-art computer and science laboratories coupled with quality day and boarding facilities, is the place to be. For more information, contact 080-233-76135. SIPS remains the birthplace of leaders.
So now we start by solving A, which is the concentration of A in mole per dm cube. So for the concentration of A in mole per dm cube is equals to the concentration of A in gram per dm cube over molar mass of A. So for the concentration of A in gram per dm cube is equals to gram over dm cube. For our gram, as you see in the question, is 1.83, which is equals to 1.83 divided by our dm cube, which is, we're given in centimeter cube, so we have to divide by 1000. That's 500 divided by 1000. So, sorry, in the question is 1.83, which is also equals to 1.83 times 1000 over 500, which is equals to this here 1, this here 2. That's 1.83 times 2, which is equals to 3.66 gram per dm cube. Next is to find our molar mass of A. So through our the acid we are using, which is HCl. So we all know that H is equals to 1 and Cl is 35.5. So that's 1 plus 35.5, which is equals to 36.5. So now we have gotten our concentration of A in gram per dm cube and our molar mass of A. Now we will now divide, which is 3.66 divided by 36.5, which is equals to 0.1100 mole per dm cube. So we have succeeded in doing the concentration of A in mole per dm cube. Now my fellow classmates will help us to do the concentration of B in mole per dm cube.
Thank you, Lydia, for the great work you have done so far. Now I'd like to have some for concentration of B in mole per dm cube. Firstly, our formula: hydrogen chloride, as we're given as the acid, plus NaHCO3, which is sodium hydrogen tribicarbonate. When reacted, they give us NaCl, which is sodium chloride or common salt, and H2O, which is water, and CO2, carbon dioxide. So now, to talk about the concentration of B, is a simple formula: CaVa all over CbVd is equals to Na all over Nb. This is the concentration of the acid, the volume of the acid, the concentration of the base, volume of the base, number of acid used, and number of base used. We have already gotten our concentration of acid, which is 0.1000. Our volume of acid, which is 23.7 centimeter cube. Our number of acid, which is number of moles the acid used, which is 1. Well, the volume of the base we have gotten is, according to our question, 25 centimeter cube. And the number of base used, which is also 1. So now to find Cb, we have to make it subject for formula. This will give us Cb is equals to CaVaNb all over VbNa. When we put our values, we have 0.100 times 23.7 times 1 all over 25 times 1. If we remove 1, this should give us 0.095 mole.
Salvation International Preparatory School. Salvation International Preparatory School.